Hello everyone, this is Ali Reza Dehkani. Thank you very much for joining my talk today. For today, I'm going to talk about the EdgeML, machine learning at the edge. We want to see why it is a very important topic, and we want to look at that from different points of view. So I actually started my work from 2015 in Movidius, stayed there for around 2 years, then joined Intel, worked there for 3 years. And then afterward, I joined an Irish startup called GeoWorks. And also after that, I joined DCU as a lecturer. And now I'm a senior research fellow at CEDA. Okay, so what is machine learning? All of us, we know about the machine learning and what's that? Machine learning is a branch of AI. Actually, as you can see from this graph in the right side of the slide. So machine learning is a subset of artificial intelligence, and also we have other subsets of that like deep learning, computer vision, etc. So this subset, this branch of AI focuses on the use of data and algorithm to imitate the way that humans learn, gradually improving its accuracy. So that's the definition of machine learning. You know, that's really versatile nowadays, and everywhere they are talking about machine learning. Okay, so if we want to look at the machine learning in industry historically, we could see it has been started from 1915. That has been the time. By 1918, it has been the time. Actually, artificial intelligence has been around, just capturing some imagination of the world, capturing the data from the world in industry. But later, from 1918 to 80 to 2010, machine learning started, doing something, gaining some traction with the environment in the industry. So it was the time machine learning was trying to do something, actually. But later, from 2010, which deep learning started getting, viral in the industry particularly, and all the other areas. So it is expected by 2040 it encapsulates the whole industry. So it is really a big topic, and it appeals a lot of attention. So let's have a look at some use cases to see why we need EdgeML. Actually, if you look at Yanmar, for example, they are a very active company in agricultural, smart agriculture, I would say. One of the main problem they are facing is administrating the right amount of water and environmental support, including fans and air condition. They want to track the situation, different stages of growth for greenhouses, to see how they can control the water, everything to do that. So they need to have cameras, everything close to the field to capture the images, and from the images they need to understand the growth stage, and based on that they need to take action. And also, if you look at Nokia, for example, you can see they need to optimize the amount of data they send to the cloud. So they need to analyze video stream at the edge and send, process, filter data to the remote center. So it's not the case to send all the data to the remote center. These are two examples. But you can find a lot of examples in industry that gives you, some understanding of the many use cases we can use ML in. It's a good idea to mention that I have brought all the resources for slides at the bottom of any page. Hopefully, I will upload the presentation somewhere, and we will link it behind the link in YouTube. And then later, if you click on any of these links, you can find the resources I have brought this slide from. So you can read more in detail for any slides in the future. So like I said, there are many use cases, but the problem is mostly of the data, they never reach the cloud. So we have medical applications, we have industrial machinery, we have extreme environment, like the space cases. Actually, even we cannot send the data to the cloud. So that's a matter of how we can process that data at the edge. So why we should use EdgeML or Edge AI or edge computing? So interchangeably, you can use these terms in different cases. The first thing is law of physics. So we don't have enough bandwidth we don't have the latency we will face is a main problem. We need to face it, so it's not possible to send all the data to the cloud. So that's one of the problems actually we face within cloud computing, and that's the reason the EdgeML would be the case. We need to process the data at the edge. We need to process the data. Maybe even we can send some metadata to the edge, to the cloud. That would be enough. The second thing is law of economics. So the cost of bandwidth is not falling as fast as the cost of storage and compute. So, you know, we are facing with three different things. We are facing with the data, the compute, and algorithm in AI. So in terms of compute, we have had a very good progress by far, but in terms of bandwidth and communication, it has not been that as fast as the other stuff. So we cannot send as much as data we want to the cloud. So that's a problem. So we need to process the data at the edge, because we are facing with billions of IoT devices nowadays. So we need to process those data. And also law of the land. So there are some sort of attack problem and the privacy and security problem. It's not possible to send all the data to the cloud. So we need to process them at the edge to make sure we are safe kind of in terms of security and so on. So these things actually were some sort of introduction. I don't want to keep you too much on these slides. Just I wanted to keep the consistency of the presentation. You will have the chance to read through the materials linked at the bottom of the slide, like I said later yourself. So, for example, look at the self-driving cars. We cannot keep waiting to see if that system tries to understand the object in the past is a rabbit or plastic bag or a human. We cannot send the data to the cloud and keep waiting for the result to be processed to see, you know, if that's the right object in the road or not. So we need to have the faster solution, and that's the reason why edge processing come into the scene. So EdgeML tries to reduce reliance on the cloud network. So instead of sending all the data to the cloud and computation take place here in the cloud, just we process the data in the devices and send some information to the cloud, not all the information, maybe the metadata, maybe the understanding we have from the data to the cloud. And if you have a look at the road from the beginning by here, you can see that was the time it was the mainframe centralized, 1960, 70. And then that was the client server distributed at the end of 20th century, kind of. Then it was mobile cloud centralized 2005 until 2020. That was the time everyone was happy about, okay, we have cloud computing, that's very cool, we can send the information. Because before that, we used to have machine learning algorithm and AI on the personal computers or computers, local computers, and then that was the situation, okay, we want to process some data in the industrial applications, and we don't have that local computer in those cases, so okay, that's okay, we can send data to the cloud. But later we saw it's not a good idea to send all the data to the cloud. So now in 2020 onward, we will be facing with the edge intelligence distributed. And the word distributed is very important, because you'll see later in my slides why it is distributed, because we distribute the processing power across the edge, not even the devices. So that would be the whole story of EdgeML. So what are the risks and benefits? Okay, you may say everything is benefit in terms of EdgeML, but it's not the case. Definitely there are some sort of risks. So nothing is absolute in the world. When you get to a new technology, when you get to a new era of technology, then definitely there are pros and cons. The benefits, low bandwidth, you don't need to send data to the cloud. High security, okay, you don't need to send important data and vulnerable data to the cloud, so you will have high security. Quick decision making, okay, for example, in self-driving cars, you don't need to send the data to cloud and keep waiting for the result from the cloud and make the decision. You can easily make the decision, and better application experience in terms of the UX. It would be fast, it would be accurate, and so on. But that's not everything. You will face with some risks in terms of control and reliability. We wouldn't have the control on the edge devices as we can in the cloud. Okay, in terms of security, okay, it is secure that we don't send the data to the cloud, but is it secure to have the data on the edge device? What will happen to the edge device? If something happens to the edge device, what would happen to the data? So do we have any backup or something? That's another problem. In terms of compatibility, so we are facing with loads of applications. Are they compatible in terms of the protocols, everything? So that's another problem for sure. Researchers and scientists will work on. And in terms of contracts and lock-in, so if that's the case of cloud, it would be probably easier to work with a few specific cloud providers and algorithms. In terms of regulations, regulatory term, it would be much easier. But if you work on the edge, definitely you need to work with loads of service providers and vendors. So that would be another challenge. Definitely in the future, lots of works will be happen on the risk and try to minimize the risk and increase the benefits of the EdgeML. Still, yeah, it is interesting, EdgeML, Edge AI, but still there are applications for cloud computing. So the edge computing application, autonomous vehicles could be one application, a smart thermostats would be another application, controlling the things at the edge, and traffic lights would be another application. But like I said, still there are cloud computing application, for example, the conventional application. So they are not maybe ready to be processed by the edge technology. Why? Maybe loads of data is generated there. Maybe the infrastructure is not ready for that. So still they need to send data to the cloud. In terms of video camera systems, so they generate loads of data. So how you can process those data at the edge? So still you need to send them those data to the cloud. For example, Evercam, one of the company we were working in EOT project with, they capture lots of videos from the camera. So definitely they need to send the data to the cloud. It's not easy for them to process all those data in the edge. And a smart lighting system, for some applications, they don't care about latency. They don't care about security stuff, etc. So still they think it's a good idea to send the data to the cloud and be processed over there. So still there are cloud computing applications. It's not like we say, okay, everything is edge and we should stay there. But there is another solution there. When I was talking about the centralized, decentralized solution, that's the fog computing. It's not just cloud and edge computing. There is another idea which is called fog computing. Over there, as you can see, by 2022, the size of this market will grow by over $6.4 billion, and it is another interesting topic of computing. So you can have some sort of computing power at very close to the edge, not close to the cloud, but close to the edge. So over here, you can send some data and process those data in here. They could be routers, servers, and so on, switches locally in different places. They can process some of this data. So you don't need to increase the power of the edge devices highly. For some of the devices, it's okay to send the data to the fog nodes, and then they can process loads of data in here. They are decentralized. They can send the information to the cloud, and then they can send back some information to the fog nodes, and they can communicate with each other and also the edge devices in here. So imagine the smart cities. In a smart city, you can have different devices, different IoT devices, I would say, in different appliances, and so they can communicate with the fog nodes. Those fog nodes, they can process the data, send back the data, and so on. That's a very interesting use cases in a smart city, which is a very hot topic at the moment. And like I said here, the cloud servers sit in the middle as the center, and we have the fog clouds in here, which decentralize the processing power, and we have the IoT devices, which they can talk about. If you look at the size of the it's different segments, we have billion devices at the edge, we have millions of the nodes at the fog stage level, and we have thousands of data center in the cloud. As you can see, fog nodes has filled the gap between the cloud and the edge. Maybe it wasn't easily possible to jump from the cloud to the edge, but now fog will help us to, make everything possible to slowly go, bring the processing compute and power toward the edge using the cloud. And in terms of different things we can discuss the fog, in terms of the benefits, it's ultra low latency, location awareness, efficiency, network load, high bandwidth security, real time. It could be intranet. It doesn't need to be internet or cloud communication. So it could be fast, real time analysis, agility, easily you can set up a fog node. So it is really interesting. Fog can help devices in terms of measurements, monitoring. Like I said, IoT devices, we have billions of them, but maybe lots of them, they are not capable of processing high level of data, and they don't have high level of compute power. So fog devices, fog nodes can help them to measure, monitor, process, analyze, and react. They can distribute the core functions, computation, storage. They can store the data at that level, communicate, control decision-making. They can increase the decision-making power. And in terms of industry, they can use in energy, manufacturing, construction, oil and gases. That's very interesting. Oil and gases, actually industry, finance, telecommunication, healthcare. That's another interesting topic. They can use the fog computing, retail, the smart city, agriculture. Again, agriculture, maybe all the agricultural machinery, it's not easy to, to support the edge devices, but maybe we can have a station in the farm to receive a lot of data from edge devices there and process the information. And okay, 5 key benefits of edge computing. Let's wrap up this part of the presentation. We are in the middle of the talk anyway. So in terms of the faster response time, we agree on that. Reliable operation with intermittent connectivity, security and compliance, cost-effective solution, and we can have connection between different devices. So there are the benefits of 5 key benefits of edge computing. We can look at that. Okay, let's jump to the second part of presentation, which is EdgeML. Like I said, I plan to talk about the hardware and the software and the firmware and the business opportunity market, etc. But that's a really big topic, so I can cover for the rest of the talk the hardware part. Maybe in another talk we can talk about the software, firmware, and market opportunities. We can have 4 different categories of the hardware for edge processing. We can process the things on CPU. We can process the thing on GPU. Everything was started from CPU, and then GPU came to the market. FPGA was really interesting all the time. It was actually kind of configurable. That was the interesting part of the story. And application-specific ICs. So in terms of CPU, we have access to multiple core. That's very interesting. Intel as the leader of the CPU manufacturing. So they have recently introduced very powerful CPU for personal computer even. And IoT devices, they can deliver a lot of compute capability there. Apple recently has introduced a new chip for the personal computer. That's the first time they try to start to get away from Intel in terms of the CPU. So that's a debate. You can find a lot of review on internet. They say, Apple claim, the battery life would be 20 hours instead of 10 hours with Intel CPUs in terms of compute power, etc. And from the other side, Intel tried to say, okay, we have benchmarked, it's not true. If it is 10 hours for Intel, it is 11 hours for Apple. So it looks like that's a debate between these big and giant manufacturer of CPUs there. So that's the main point, multiple cores and mixed data input. Like I said, in terms of GPU, highly parallel cores, that's the main point. But the problem is they have larger footprint and higher power consumption. You need to have really cooling system for the GPUs. In terms of application specific, they are configurable logic gates, less power than CPU and GPU. I think I have not updated that for the FPGA, sorry. In terms of application specific, I will bring it here. In terms of application specific, they could be really specific and highly optimized in terms of computation and power. They can go even sometimes behind 1 watt for computation, but the problem is they're really specific to a specific application. It's not easily extendable to other applications. In terms of FPGA, like I said, they are configurable. They consume less power than CPU and GPUs, and they have high degree of flexibilities. We can summarize everything in here. In terms of CPU, GPUs, and DSPs, we have NVIDIA, we have Intel CPUs, we have Arduino, ARM cores, TI-6X, and Qualcomm. They are the most famous ones. In terms of specialized processors, we have different kind of them. You can see Intel Movidius in the second line. That's one of them, one of the famous one. And also we have licensable cores. The platforms actually that give you computation power. For example, you can search them, you can find them, which they are really interesting. In terms of mobile SoCs, we can find different platform again, which give you the processing. The mobile industry, according to one of my colleagues in Movidius and Intel, he used to say, you don't buy mobile, you buy camera. If you say you are buying a new mobile phone, that's very interesting, lots of camera, it has, I can capture images, blah, blah, etc. No, you are buying camera, you are not buying mobile phone. It's not mobile phone. So that's the reason why mobile company manufacturer, they have spent a lot of energy to develop the new chip. And like I said, Apple started the new chip for mobiles, for iPhones and tablets, iPads. And then later, after testing a lot of technologies, they have brought that technology to the personal computers also. And in terms of FPGAs, you can see Xilinx, Ultra, and maybe some other cases. All of these cases can be discussed in separate talks. And also it's a good idea to keep that in mind that we have the heterogeneous computing. So compound computing using combination of, I forgot the word, the combination of different hardwares can bring heterogeneous computing architecture. That's a very famous book. If you are interested in, you can read that book, Heterogeneous Computing Architectures, Challenges and Vision. But that's the story of refer to systems that use more than one kind of processor or cores. This system gain performance or energy efficiency not just by adding the same type of processor, by adding this similar coprocessor and so on. That's one of the advantages of using application-specific ICs. If you remember those 4 categories in here, application-specific ICs. In them, since you are designing that specific ASIC, sorry, so you will have the chance to bring this computational power together. For example, in Movidius, we used to do a lot. We used to bring FPGAs along the Movidius chip to increase the processing power. So I don't want to go to CPU. Intel has introduced, like I said, different new hardwares for the processing, for the edge processing, EdgeML, for example, 11th generation Intel Core vPro and so on. I don't want to go to them. And in terms of Atom, also Intel has introduced a lot of hardware, interesting hardwares, but I want to focus on Movidius hardware, which is called VPU, Vision Processing Unit, and Intel Myriad X VPU, is the third generation, the most advanced VPU from Movidius and Intel company. So it was started with Myriad 1 in 2006, and then in 2011 they introduced the second generation Myriad 2. Almost, I would say, they couldn't make any success with Myriad 1. 4 years, lots of funding, they couldn't make anything. That would be a very good point for the entrepreneurs. After 4 years, probably will give up. But they changed the idea, they pivoted a little bit, they received new fundings, and they started Myriad 2. At the time I was working in Movidius, that was the, the flagship product of the Movidius Myriad 2, but later we introduced Myriad X, and recently, as far as I know, and I'm not sure if I'm allowed to say that, they have started to change the naming strategy. It wouldn't be Myriad X, Myriad Y, Myriad Z, it would be another naming strategy. So the main point is it has 16 shaped cores, RISC processors, ultra high throughput intelligent memory fabric. I will discuss all topics in the following slides. Upgraded and expanded vision accelerators, and so on. I will go through the details later. As you can see, that's the size of the chip in here. In terms of the data exchange, traditional architecture was like that. We had the CPU, DSP, other accelerators, and they needed to exchange the data between each other. So it was lots of energy used to be consumed by fetching and sending data between these modules. But in Movidius, in Myriad, Movidius VPU architecture, I would say, we have intelligent memory fabric. All the data is stored in there. So you don't need to exchange the data between different sections in the chip. Actually, all the data is available here, and you will receive and send the data to this section. So it has decreased the power consumption a lot. That has been the main advantage of VPU, Movidius VPU architecture. The second thing would be lots of hardware optimized vision and image processing accelerators. That accelerator plays the main key role in the Movidius architecture. So we have lots of them. They do a lot of things. For example, the one I was working on was event processing unit. So we could send CPU to the standby, and if something happens in front of the camera, that unit used to process the images. If something happens in front of the camera, or even if any changes in audio happens, then we can send a message to the CPU, to the VPU, and say, okay, wake up, there is something interesting and you need to process that. And there are loads of them. Like I said, in terms of in terms of stereo vision processing, we had the accelerator there. So you needed to implement, you didn't need to implement to the stereo system as a code in your platform. That accelerator used to get the images, analyze the images, generate the depth map for you. That could be the same for lots of the accelerator. Like I said, we had the FFT processor. It could calculate the FFT for you. It could calculate the interest point in the images, and so on. So these accelerators are really interesting in Movidius VPU. And like I said, in Intel, lots of people in the team, they are working on increasing these accelerators and improving their performance. Another interesting thing in Myriad is the parallel processing. We have 16 RISC processor in here. They can share the processing power between each other. So you don't need to, use a GPU. You don't need to use multiple coring CPU. That's really sophisticated and dedicated vision processing unit with multiple core that you can, share the processing power across 16 up to 16 different cores. Like I said, for you, you may think, okay, that would be interesting to share the processing power over all of the 16 of them. But that's not the case. There is a kind of trade-off point. You need to see how is the power and computation, etc., on how many of these cores. It's not the case. If you use more cores, you will have more better performance. No, that's not the case. You need to benchmark it to see which one is the best case for you. Maybe sometimes better to do everything on one processor, and for some task and application, maybe it's better to divide it on different processors. Deep learning neural compute engine is another interesting part built inside the VPU processor. Like I said, we started that maybe in the second half of 2015, yeah. We started that as a really simple project in the R&D team. What was that project? That project was actually for the LeanIt. You know, the LeanIt is the simplest CNN model. You can do the probably digit recognition. Lucan actually introduced that model. So we started with MATLAB and C to implement that LeanIt in C and check the output of each layer to see if it is similar to MATLAB. The master student was doing that. And then we continued, we got to a library which we could implement a neural network in Movidius VPU. You know, Movidius has its own compiler. The language we use for Movidius is C and C++ to develop the code. There is a firmware there. You can implement the application for Movidius VPU MyriadX, let's say. So we can talk about that in another talk, probably. There are lots of information regarding that. So NCE runs AI algorithm in parallel with other imaging and CV algorithm. That's another interesting point. So we may probably have other hardware platform specifically for neural computing, but that's the case. What about if you are trying to do something, a traditional CV algorithm on the platform? Okay, Myriad support that. And the interesting point is it could be run in parallel to the neural computing over there. So that would be interesting. So they can exchange the information. So you may have an application, you want to do some part of the processing using the traditional computer vision algorithms, and maybe the rest using the neural networks. So that would be possible in Myriad X, actually, I would say. And the next interesting point is you can have multiple of these processing unit together to create edge server. So you can generate kind of a PCIe form factor accelerator card. You can install it in your system, in your server, and that will multiple the processing power of your system to do much more of the processing. Okay, so that's not all. Intel has introduced another platform, another toolkit, which is called OpenVINO. OpenVINO use a lot of other open source. This is open source. Lots of other open source toolkits, including OpenCL, OpenCV, and so on. So you can use OpenVINO to compile deep learning algorithm to run on accelerator cards and scale AI performance at the edge. So that's the main problem. The first step for the businesses is to create a prototype. But for creating the prototype, you cannot spend a lot of time, years or even months to develop something and then show it to the market to see if it is a good idea. Okay, invest on my idea and so on. No, you need to do that as fast as possible. So OpenVINO, along with the Intel hardwares, Intel Movidius hardware, will provide that opportunity for startups and companies and SMEs to implement their idea, to develop their idea using OpenVINO and the platform. Like I said, you have in the OpenVINO toolkit, you have some sort of the network, pre-trained network, maybe even the customized network, you train yourself, and you have some sort of toolkit in here, and you have the hardware, you can import all the hardware, all the implementation to the platform and run the algorithm on the edge. So that's another interesting part of the processing. So let's have a look at NCS2, which is the second version of NCS. NCS1 was in Movidius at that time. NCS1 happened at the time Intel was buying Movidius, and then now we have NCS2. So from the beginning, the design was like this: the blue color of the Intel with the Intel logo on it. But everything was started from another platform, which was Fathom, what was called Fathom. Fathom was the maybe the parent of NCS. In the Fathom, that was the very beginning library we introduced. You could do a lot of processor. It was like the USB key. You could connect it to your computer. You could train some sort of the model using the library and framework. You could import the network to the platform, which is here. It had the Movidius VPU Myriad X on the board, on the form factor board in here. And then you could run the algorithm on the hardware to see how it works. Well, like I said, later in Intel, we have Myriad 2. That's the first version. And that's the second version, which has Myriad X. And so you can develop, you can fine tune and deploy CNNs on low power applications with real-time inferencing based on Intel Movidius Myriad X VPU. So deep learning inference at the edge, pre-trained model on open model zoo. I'll talk about all these things in the coming slides. So it will provide you with a lot of capabilities. Before that, in Movidius, if you wanted to use the platform, it wasn't like the current NCS or maybe Raspberry Pi or maybe other platform. You could go to any website and buy it for maybe $100 or something and try something yourself. No, it wasn't the case. If you wanted to have access to the platform, you needed to spend $250,000 on the table at least. Then the negotiation used to be started. So then from the time Intel brought just NCS2 to the market, they made it possible for even individual people to play with the platform to see if they can develop something based on that. So nowadays in the schools, even a student, they can buy one of them with the price of $79-ish, something like that on different platforms, websites, etc. And they can run the student project and so on. They can create a prototype for an application, even for themselves if they want to do something. If they want to run a smart device at home even, they can use this platform. Okay, they can take different pre-trained models. So they can support different frameworks like TensorFlow, Caffe, Apache, MXNet, and so on, PyTorch, and so on. So they can support different platforms. And also they can support different operating systems. You can work on Ubuntu, Windows, Mac OS, even Raspbian for the Raspberry Pi. Yes, you can connect it to Raspberry Pi, and you can take a lot of information from sensors on Raspberry Pi, and then you can have a processing, neural computing processing power on NCS connected from the USB port to the Raspberry Pi and so on. So what could be the use cases? Like I said, the plug and play power of Intel NCS2 is very important. So you can connect it to any USB devices, single board, and generate single board computers. If you don't have that processing power on the device, on the development card by yourself, then NCS will help you to have that processing power. It could be Raspberry Pi, ARM host devices, and so on, with a very low cost edge device. Okay. Even you can connect it to a computer like this. So you can connect it to your computer and you can have the processing power. And also even you can have a depth sensing camera from Intel, for example. You can connect this in here. And like I said, you can create a smart CCTV for yourself at home or at your workplace. It wasn't possible maybe a few years ago, 5 years ago, and so on. But it is possible now, easily. Let's have a look at OpenVINO a little bit to see what's OpenVINO and what does it do. OpenVINO, like I said, that's a toolkit which provides you with lots of capabilities there, support heterogeneous execution. You can run your codes on CPU. It's not only for NCS, you can run it on GPU, on NCS, speed time to market via easy to use CV functions, and include optimized call for CV standard. Like I said, it includes OpenCV, OpenCL, and OpenVX. When you install OpenVINO on your computer, it installs all this library by itself, and then you can use it over here. If you want to compare deep learning with traditional computers, with traditional computer visions, you can see in traditional computer vision that was only the matter of CPU and GPUs. You could do the specific stuffs, and you need to have a lot of interfaces yourself. You need to have a lot of libraries, tools, kits, etc. in here, and also connect this in here to do that. But like I said, OpenVINO will provide everything for you in here, and you can use CPU, GPU, FPGA, and even VPU. You can run your algorithm on FPGA using OpenVINO. So that's really interesting. And like I said, it supports different frameworks like TensorFlow, Caffe, and so on. The two main core of the OpenVINO is the model optimizer and inference engine. So you can pick a pre-trained model, and also you can train a model yourself in all of these platforms, and then model optimizer optimize this model and generate a specific format of the model for the OpenVINO and the device in here, and then send it to inference engine that can inference the application you are working with, and then it is connected to different hardware platform. You can run the inference on those hardware platforms. Like I said, you have the training phase, you have the prepare optimize, you have the inference, you have the optimized heterogeneous in here. So you can use even multiple platforms in here, and you can also extend it. You can get the output and generate more sophisticated output yourself. So that's the combination of all these tools together to generate some sort of applications in here. An interesting part of toolkit, OpenVINO toolkit, is Open Model Zoo. If you go to this address in here, like I said, all of these things, they have hyperlinks. So if you click later on the slides, you can go immediately to the link. So you'll have access to loads of pre-trained models. You have some sort of demo applications. You can take a demo, customize it yourself to create your own application. And you have also lots of tools over there, accuracy checker, model downloader, and so on. So you can download the model, even port it to your hardware specifically, another hardware. So that would be really interesting, another point of that. Like I said, in Open Model Zoo, you will have a lot of that's a open source repository for pre-trained model in different areas: object detection, face recognition, object detection model in here, human pose estimation, which is very interesting. In Intel, I worked on a demo for driver distraction application. It used to look at the driver face to see if driver is looking at the road or camera or mobile phone or something like that. So there are lots of pre-trained model in here. You can play with them, but like I said, you can even train your own model and use the OpenVINO. Like I said, there are lots of applications, demo applications there. You can take the smart classroom demo, for example. You can take it and customize it. I don't know, maybe yeah, there are lots of in here. Text-to-speech Python demo even. It's not like image processing. You can take any of these demos, customize it for your needs in here. So it's really easy. For example, in Linux, using a bunch of code. I'm not going to go through the detail of the code in here, but just I wanted to show you how it works. There are very good documentation there. Easily you can get connected, read about it, and understand the detail of the things in here. And then, like I said, you can make the code you have developed and run it. And then easily it can work on the images you have captured from the cameras. So run the sample application on the Intel videos. So that was running on the PC, but you can run it on the hardware. Like I said, again, in the documentation, you can find all these codes, how to run it on here. And the interesting part is chaining model. You can use multiple models to do different things. One could be, for example, object detection, detecting the car in here. The second thing would be probably text detection to detect the numbers and text in here. And then it could be even anomaly detection. So you can use different models in here to do different things on different hardware and platforms. It is really interesting. When you introduce a really interesting technology, there are companies who wants to create something on top of that technology. So that's grabbed my attention. If you go to this website, you can buy it even. So you can buy Intel Vision Accelerator designed with Intel Movies. You can buy a card kind of powered, let's say, what is that? That's a toolkit powered by Open Visual Inference and Neural Network Optimization. So you can buy this kind of the card. It has everything in it. You can use AI, machine learning, deep learning, convolutional neural network. And like I said, it supports the OpenVINO. You can do everything on the platform in here. Okay, let's jump to the Eyes of Things project a little bit. It is interesting, just I wanted to talk about a little bit in here. That was the project I was managing. I was the lead of the hardware design in this project. You can compare the size of the board. That was the platform board we designed for the project. That's the size of the board in comparison to 1 euro coin, 4.5 by 5.5 centimeter. Even it could be smaller because, as you can see, we have provided with lots of development capability at the edge of the board. You can have access to the GPUs in here, to the pin of the movies in here. So it is very interesting for the developers if they want to develop a new code and application to do something, for example, in terms of robotic, they will have access to all the pins in here. They can mount a specific device in here, like I said, everything. This board is based on Miria 2. It used to support multiple cameras. I remember that's an extension board for the camera. I remember we used to support 6 different cameras in here. For that, it would be very interesting for drone application. You could have 6 cameras on 6 different directions to capture the images and then navigate the drone for yourself. We will have audio capability in here. We will have a GPU. Let me find you the GPU. GPU is here. FPGA. FPGA is here. That FPGA help us to get connection to a medical camera, which is really low power camera and tiny camera. And here it would be robotic connection. So you can connect any robot, etc., to this part to do anything you want. That's the micro USB in here, as I said. And yeah, so that's the SD card, micro SD card. We didn't have this capability on Movidius development board, and also it is battery operated. We didn't have battery operated before this board. We didn't have micro USB. We didn't have micro SD card. We didn't have that extension in here, robotic, etc. In the EOT project, we introduced all this capability. And also in terms of the size, it is kind of the half of the size of the Movidius platform. So that was really a good achievement we got in here. That's the Wikipedia page of the project. And if you click on this, that would be the website of the EOT project. We have made it available, all the design, etc. there. So just you can go there, get the form factor design, everything, even the list of component on the board, etc. And I think this device is accessible through Intel. If companies, they want to develop something, they can go to this platform, they can negotiate with Intel, buy this platform and work with Intel. Even I think you don't need to go to the Intel, even Eyes of Things project have the authority to give you access to this platform. And that's the the block diagram of the design we used to work on it. I remember in the beginning of the talk, I said I had the chance to work with David Maloney, really passionate entrepreneur. I remember this block diagram used to change every day. He used to come to the meeting and say, oh guys, we want to have this capability also. Let's add something to do that. Let's add this thing, let's add that thing. And that was the reason why we added that Taiwan camera in here. That's really interesting camera. We could bring lots of camera in here and different capabilities. Like I said, we changed the power system of the board, of the platform, different from the Movidius previous Movidius development platform. So, and in the project we had 4 demonstrators. It's interesting to see in terms of the hardware, what was the roadmap. We started with the development board. This part is the Movidius development board. The size is twice of the size of the EOT platform we designed. We connected some sort of the other devices to this board, and this big giant platform was the very beginning thing. In 3 months, as we delivered that to the software partners of the project to make it possible for them to play with the device. And then later we from this one we went to this one. That was the second one. By the first year of the project, that was 3 years project, we got to this board which had all of these capabilities in here, and that was the final form factor one. We wanted to make it even smaller, Well, like I said, that was the timeline of the project, and stopped doing that. If you want to have it on the specific application like the NCS, it could be like the flash memory. You don't need to have lots of these capabilities. Even it could be 1 by 1.5 centimeter size. That's all. You need to take this guy, and it doesn't have too much peripheral. Do you remember I talk about the accelerators and all the stuffs inside the VPU? You don't need to have lots of peripherals outside. Everything is inside. And the demonstrators was the pinhole demonstrator. You use to keep the device in front of the door pinhole. It detects the images other side of the door, detects the anomalies in here. The live logging, you can connect the device, hang it from your neck, for example, walk in the street, and it captures the images and so it gives you some information. The museum demonstrator, which was really interesting, you hang it from your neck, walk into the museum, it detects the painting, recognize the painting, get connected to the audio server, you have a headset on your head, and it tries to play a demonstration about that specific painting. And the smart doll was another application. We installed the board inside the head of the doll. Eyes are the, it was supposed the eyes to be the camera of the system, but the camera is in here. That camera, when the kid is playing with the doll, it detects the face of the doll and recognizes the emotion and say, okay, kid is happy, hungry, sad, and so on. So that was interesting. We had some sort of ethical challenge with this demonstration. And then finally, we constrained that to hospital usage and so on. So that was the demonstrators in here. Like I said, it is possible to use that EOT platform in different things. Abotica is a company in Cedar. We have been interested to work with them. There are some of the Movidius Philo employees. They have started this company. They are working with the EOT platform. They have developed a new board based on that, which is called UB0100 CubeSat board for AI and computing stuff, etc. So that's very similar to the platform we had for the EOT. As you can see, this guy here is Aubrey Down. I used to work with him for 3 years on the EOT project. He's at the moment the VP of engineering at Abotica. One of the projects recently they have worked is with the European Space Agency. They have installed their device over there to measure some sort of the heating and radiation, etc., before sending the spacecraft to the space. So it could be interesting if someone wants to work with this company to get their platform, their form factor platform, to do some sort of the things. I wanted to stop here, but just a few slides about the other platform and development board. NVIDIA also introduced Jetson Javier NX, and also this development kit. That's the CPU, that's the core actually in here, and that's the development board altogether. It delivers lots of Edge AI and EdgeML processing power in here. Qualcomm also has introduced 3 new AI accelerator chips in here. You can compare it in terms of power and throughput, in terms of processing power and power consumption. As you can see, the less is the better, the more is the better in here. So as you can see, Qualcomm devices sit in here. In terms of the power, these 2 devices are very good, less than 50 watt, but in terms of throughput, they are lower than Intel platform, NVIDIA, and so on. There is nothing absolute in here. That's up to application. You need to see which platform works the best for your application. AMD also has introduced some sort of the devices in here. I don't want to go through the detail. EPYC embedded 3000 series is that kind of the devices. And ARM also, they have focused on heterogeneous computing and using different things to make more interesting platform processing. So that's the end of my presentation. I finished it in roughly, I think, 50 minutes. And so you can find me in my website in here. My social media everywhere is ARD24IE, including my YouTube. And that's my LinkedIn. Again, like I said, that's the hyperlink in here. And I would be happy to work with you, help you, and learn from you also if there is anything. Thank you very much for listening to my presentation.
Thank you, Alireza. That was an excellent talk, very informative and easy to follow. Just we're short on time, so if there's any questions, if anyone wants to unmute themselves or the question in the chat.
So we stop the recording.